In this video, we are going to learn how to use section designer for checking the columns of existing buildings or structures. First of all, we have to take a look on the existing columns. The material properties are given, the floor height configuration is shown, the center to center span is 18 feet, the slab properties, live loads, super dead load, and the seismic configuration is shown. The framing type is moment resisting and it is a residential building. We have to use UPC 97 for seismic load. To check column design, ACI code. The framing is shown. The section of the column C1 is shown and a section of column C2 is also shown with reinforcement details. Now we will be modeling the structure on Etabs. Starting with defining grids. So the 3D grids are ready. Now we will be defining the material properties. The concrete property as we were given is 4000 KSI. The rebar property which we have checked. Now in the next part we will have to define the section property for the existing structures. Let's read the useless properties which are given by default. Okay. Now we have to add the property using the section designer, which is for the existing columns. Because we can define reinforcement here, let's start with the section designer. Let's check on concrete column. Reinforcement to be checked is selected. A column is 12 by 12 inch. Click on section designer. Click on draw rectangle. The material is selected. Now right click. We are getting the dimensions of the column here. Reinforcing is used. Material is 16. We have to change the rebars. We have to enter one bar in the corner bars and 2 bars in the edge bars. So the edge bars are defined as 3. We have to change them into 2 so that the arrangement is according to our requirement. Tie bar is selected as well. Similarly, for the rest of the edge bars, we will have to repeat the process until all reinforcing bars are defined. The 12 bars are defined now. So you can also check the properties of the section here. Entering the moment of inertia property modifiers using ACI code. The reinforcement is to be checked. Delete the property of the remaining useless section. Now defining the property of the slab. Incorporating ACI property modifiers for the slab. Let's edit them with interior and exterior naming so that modeling will be distinguished for interior, exterior, and as well as the checking. Defining the load patterns, adding the super dead load, seismic load using UBC 97 in X and Y direction. Using soil type SD. Now the seismic zone is 2B and the frame is moment resisting. So for 2B we take as intermediate moment resisting frame. The value of C and C will automatically be selected by Etabs. Just to cross check, we have shown here. The factors of R and I are shown using UBC 97 chapter 16. So the properties which we have shown with reference to UBC 97 are input here. Defining the mass source for the seismic inertia. We have to add all the dead loads here in the case of mass source. Now we will be required to model the structure according to the given framing which was shown in the beginning of the video. Let's start with modeling the exterior columns. And then the interior columns. Draw the slab of 8 inches. You have to mesh the slab. The meshing size allowed is maximum of 3 feet by 3 feet. You can also visit the channel and watch the meshing videos for the rules. Right now we are assuming that the meshing videos are watched. So dividing the slabs into 6 by 6. Now we will be required to assign the loads to the slab since live load and the super dead load are present on the slab. So the loads are uniformly distributed as live load and super dead load. The live load is 40 psf. and the super dead load is 20 psf as shown previously. In order to cross check the loads, we'll right click on a slab meshed portion so that it is confirmed that the slab loads are assigned. Now we'll turn off the visibility of the floors and select all of the columns and go to design. Select sway intermediate. Since the framing is moment resisting frame and the type is intermediate moment resisting frame, the code to be used when checking the design is ACI 314. Now the load combinations default will be added according to ACI 318. Convert to user defined so that if you have slight editing, you can edit the code combinations here. Concrete frame design, the combinations are already added here. Now we are required to assign the diaphragm to the slab, which is to distribute the lateral forces. Now replicate the slab to the stories. And assign the diaphragm to the new story. Make the supports fixed. So the structure is modeled as shown. Now adding the P delta option, which will induce the secondary moments caused by the deflection of the structure. Now running the model, let's name it as check model. If you want to see how the column is designed, you need to visit the channel and check for the videos related to design of intermediate and special moment resisting frame. Now we will design the click on design and check of the column. Since it is a check model, so Etabs will check the model as reinforcement is already assigned. Now the Etabs color shows that the model columns are okay in design. Let's turn off visibility of the rest of the objects apart from columns. The stress ratio is less than 1, that means the column is okay. Now we will be checking the effective length factor. Usually in software, conservatively we take a factor of k if the column is fixed from top and bottom. So the effective length factor k is given as 1. Sway and non-sway factor also 1. Here the capacity ratio is still lower than 1, so the column is okay. Rebar ratio is less than 4% or 8%, that means the column is okay and the reinforcement is within the limits. Let's rotate the model a little bit. Now checking the shear reinforcement. First, we need to know the criteria for the intermediate moment resisting frame using ACI code. The shear reinforcement we are getting here is 0 in most of the columns. Rather, we are getting 0 shear reinforcement. Let's design it again. But still we were getting 0. Let's check the limitation for IMRF ties whether the shear reinforcement input is minimum as well. 8 times diameter of the bar, 24 diameter of the ties, half of the smallest cross section and 12 inches. These are the minimum spacing criteria for IMRF ties, intermediate moment resisting frame, over the distance L0, whose definitions are shown. If the spacing between adjacent longitudinal bars is greater than 6 inch, then we provide alternate ties, which is not in our case, so we will skip that part. Calculating spacing limitations for ties. First gives us 6 inch, second 12 inch, third 6 inch, and the last is 12 inches predefined. Hence the ties spacing shall not be greater than 6 inch, which is our case. So the shear reinforcement is okay. Let's apply it again and check. There is no reinforcement exceeding. The reason for shear reinforcement being 0 is that shear 5Vs is greater than the 5Vc or 5Vn. Hence the steel that is input in Etabs is already enough to control shear. That was minimum shear steel. Note that previously I told how to check the effective length factor. You can always check the effective length factor of the all columns, just similar to the reinforcement we check by displaying the effective length factor on the columns from using the design input and the effective length factor. Similarly, you can check all the different things like design type and other things as well, such as DNS factor, sway, non-sway factor, etc. CM factors, which is also important in design of sway or non-sway frames. Design sections. Additionally, we have to check the limits for drift due to seismic loading, the drift due to wind loading, and the torsion irregularity. Since it's roll rise, so the wind will not govern nor it is in design or serviceability check. But in order to understand the limitations concept, you have to go to the basics which I have discussed in previous video for design of special moment resisting frame and detailing. Thank you for watching and visit channel for complete Etabs tutorials and much more to come.